Wireless is where it's at these days. I mean, I don't know how you feel, but I am so done worrying about cables and wires connecting up all my stuff. If it was up to me, everything would be wireless. Of course, I'm tired of plugging my smartphone into my computer, and we all have a drawer with about 500 cheap USB cables that came with just about every single product we've bought for the last 10 years. Sorry. Got a little carried away there. Of course, every wireless standard has its range and the things that it's good for. We all know that Wi-Fi is good for about as far as you can throw a softball, and we can use it to pass a lot of data between our various computing devices. We also know that Bluetooth works about as far as we can talk to another person and opens up another range of applications. But what about the close-up stuff? What about applications that only need a few inches to a few feet of range to communicate, and don't have a bunch of power available at both ends to pull that off? Hi, I'm Amelia Dalton, host of Chalk Talk, and as you might have guessed, today we're talking about near-field communications, or NFC. My guest is Greg Proehl from STMicroelectronics, and we're going to go over the basics of NFC technology and explore some of the cool and innovative new NFC solutions from ST, including one with energy harvesting capability. Yeah, I know. I'm excited about that part too. Before we get started, I want to remind everyone that you can click on that Download Now button below your player. There you can download a free white paper that further expands on this topic. Welcome, Greg. Thank you so much for joining me today.
Oh, thanks.
Lately, I've been hearing a lot about NFC, but I don't think I really get what it is. Greg, what is it?
I think before we get into the world of NFC, we really need to start first with RFID.
All right.
So RFID, as you know, is radio frequency identification. And the basics of the technology is you have an emitter and a tag.
Okay.
The emitter controls the conversation. It initiates all the commands. So, hey, tag, take this info. Hey, tag, give me that info. And the tag communicates bidirectionally back to the emitter.
Okay.
The tag also picks up energy from the emitter and self-powers itself.
Right, okay.
And it does that through inductive coupling. So the antennas that are there aren't your traditional TV antennas.
Right.
They're basically, the best way to think about it is actually an air core transformer.
Oh, okay.
So you have a primary and you also have a secondary, and the magnetic field transmit the energy from the primary to the secondary through the air gap.
Cool, okay.
So when you talk about NFC, the fundamentals are exactly the same. With NFC, the main frequency band is 13.56 megahertz.
Okay.
In RFID, you traditionally have a bunch of different frequency bands, the main ones being low frequency, high, and ultra high frequency. But NFC has defined the frequency that they use in 13.56 megahertz. Also with NFC, it uses the same communication protocols as RFID. So it uses 14443 for a short-range, high data rate communication, and it then uses 15693 for a longer-range, lower data rate connection.
Ah, okay. So Greg, before we go on, tell me a little bit more about these two protocols.
The main things that you need to know about the two protocols, as with any ISO protocol, those two protocols have their maximum power defined by the specification, the data rate and modulation scheme. But when you look at those two protocols side by side, you can see that the data rate for 14443 in NFC is about 106 kbits per second. And for 15693, it's 26 kbit per second.
Okay.
But the read range distance is significantly different for the two.
Yeah.
10 centimeters versus 1 meter.
Yeah.
And when you look at these two distances, that really is at the maximum power that the readers can produce. When you look at it from a cell phone perspective, it's about a half inch for 14443 and 3 inches for 15693.
Okay, Greg, I think that was a good lesson about RFID, but we're here to talk about NFC, right? It's similar to RFID, am I right?
Yeah, you're exactly right. NFC is exactly the same as RFID fundamentally. It uses the same communication protocols. But what the NFC Forum has defined as part of the communication is they've defined how that data is structured, so that when you're talking with another NFC device, the structure of the data dictates how that data is routed in smartphones or tablets, etc. So in general, NFC is a subset of RFID.
All right, okay.
Also with NFC, each NFC device can act like a reader-writer or an emitter, or each device can also act like a tag. So it's important to know where you are in the NFC infrastructure so you can support one or all of the main NFC modes of communication. Those main modes of communication are reader, card emulation, and peer-to-peer modes. In reader mode, it's traditional RFID. Hey, I have a phone. Here, NFC tag, take my info. Let me read your information.
Okay.
In card emulation mode, it's a little bit more advanced where your device can be a reader-writer or it can act like an NFC tag.
Okay.
The traditional use case of that has been in payment systems where you have a point-of-sale terminal.
Right,
and that point-of-sale terminal needs to be a reader-writer or it needs to also be a tag at some point in that conversation.
Yeah.
In peer-to-peer mode, you can have any device at any given time start a conversation with another device that supports peer-to-peer mode. And that's a very important concept for people to understand because it has nothing to do with the bidirectional communication because you get that in all the modes. The most important thing about peer-to-peer mode is to understand that it is any device can start a conversation at any given time. So that can be important in some examples, but in other use cases, you don't want your mouse to start a communication with the PC.
Right.
You want your PC to drive that communication.
Yeah, that makes sense.
Also, when you look at the data rate and the read range of NFC, you might think, man, maybe 100 kbits, maybe a few inches of distance.
Yeah.
What is it really good for?
Sure.
Really, NFC is being looked at as a complementary technology that drives connections to Bluetooth and Wi-Fi devices. So its short distance and data rate doesn't allow for you to send a 100 meg video file because we'll see you in a month.
Right.
It's not very practical to most users.
Okay, Greg, so with all these modes, it seems like we could use NFC for just about anything. How do you organize that and keep track of all the different kinds of applications people are working on?
That's a very good question. When you look at NFC market segmentation, it really is important for you to understand where you want to play in NFC infrastructure.
Right.
If you are a mobile device, you really want to look for products that are designated for mobile devices because you will need to support all the different communication modes. Plus, you'll also need to have access for a secure element to your product so that you can then process payments and participate in the point of sale infrastructure.
That makes sense, yeah.
For most use cases, people will need to be in the embedded NFC and NFC tag markets where you're wanting to simplify the connection of consumer products, games, or industrial machines to a NFC phone or tablet. So when you break down the NFC market segmentation into actual products and you look at our portfolio, we have products from NFC tags all the way up to full mobile NFC controllers. So when you look at this list, the system cost as far as product expense and system complexity increase as you go top to bottom.
I see, okay.
So NFC tags, obviously very simple. We have some wired tags that expand on the NFC tag concept, but then we also have full reader-writers, transceivers, and controllers.
Okay, Greg, that's a lot of stuff to cover in that portfolio. What's the basic NFC infrastructure look like?
Right, if we boil down the basic NFC infrastructure, you have the mobile phone at the hub of that communication mechanism. Inside that mobile phone, there's an NFC controller.
Okay.
The NFC controller controls the conversation with the phone to the tag.
Okay,
it also passes the data up to the mobile SoC to the web. When you look at the structure of an NFC tag, Inside that tag, there's an area of memory called NDEF. That's the NFC Data Exchange formatted area. In that area, you have a format that is dictated by the NFC Forum. It's basically a wrapper around the data that's stored on that tag. So you have URL, pair, SMS, email, phone, vCard, and phone config, just to run through some of the tags that are controlled at the high levels of Android. After each of those header tags, you'll have strings of information. And those strings of information is how Android knows how to deal with and where to pass the information to its own built-in apps in its OS.
Gotcha, okay.
That's the basic NFC infrastructure that most use cases will have to deal with.
Okay, Greg, I think I understand the basic architecture, but how are these being used?
The basic use cases for NFC with this infrastructure is mainly the tap and pair and tap and exchange use cases that you'll have in NFC. There's also tap and go, but that's primarily focused on point of sale terminals, badge access systems, and things that might be on a phone.
Gotcha.
Tap and pair and tap and exchange really are use cases where a majority of consumer peripheral products would be located, or different healthcare metering and home appliance applications are located. And those are the main use cases that NFC will be driving in the future.
Okay, that makes sense. But Greg, I think that describes about 1 billion applications, doesn't it? I mean, are we going to be here for a year?
We could be, because when you look at the target applications for tap and pair and tap and exchange use cases, and you put those into specific markets, and you'll find that most things can now be connected with NFC.
Yeah.
There really isn't anything that you probably couldn't connect with NFC. So, yeah, you are right. It could be a year, but...
All right, Greg, let's jump down to some specifics. This sounds a bit complicated. How would I go about implementing this?
Yeah, the simplest way to implement NFC connectivity is a product that we call the M24LR.
Okay.
That product is a DualInterface EEPROM.
Okay.
And the best way to think about that product is a RFID tag that we added I2C interface to.
Okay.
So it allows you to connect to a block of memory with RFID or NFC, but now that same block of memory can be connected to with I2C. With this product, too, we have a unique energy harvest function added to it. And the way to think about that is when an emitter gives an RFID tag energy, and the tag uses that energy to wake up, we harvest whatever energy was left over that the tag didn't use and put it on an unregulated voltage output pin.
Wow, very
so
cool.
Now you can maybe power a little sub-autonomous power system in your application and configure things and maybe do some a little bit more advanced things without having to use batteries or supercaps.
That's cool.
This product is also built on our high reliability EEPROM process in ST. As you know, we're a market leader in eSquare, and this is a fundamental technology for this product as well.
Great. Okay, Greg, let's drill down and see what's inside this bad boy.
When you look inside the M24LR, it's a very simple device. Like I said, it's really built on our fundamental EEPROM technology. It has an I2C interface running at a maximum of 400 kHz. It also communicates through the RF interface through 15693. But you'll notice we add a power management and I2C arbitration unit as well as a power extraction unit inside the block diagram to give you that harvested energy on the V out pin. We also have a RF work in progress busy pin to let the product connected to that I2C interface know that there's activity going on the RF side so that it doesn't try and access the same block of memory at the same time as the RFID interface.
Yeah.
So now when you look at the basic NFC infrastructure that we had talked about before, and you look at how it changes with the M24LR interface added to it, now you have that block of memory being able to be accessed through the I2C interface.
Okay.
So now Again, it gives you a very simple way to do NFC connectivity because your mobile phone looks at the tag like any other NFC tag, but now your embedded system looks at it just like any I2C EEPROM. It doesn't know any difference, so there's no software complexity running on your SoC side. So again, the product's unique. We add the I2C interface, the energy harvesting, and we have a bunch of different memory sizes to allow you to do simple connections or more complex data logging.
Okay, so what additional capabilities does this expanded infrastructure give us? What cool stuff can we do?
Well, when you look at using this product in your device, now you have to look at the device's whole use cycle.
Right.
So from manufacturing and logistics through the end user to a servicing and maintenance phase, you can use this device to program devices on a production line with RFID.
Oh, okay.
Now you can envision taking your device, building it ahead of time with no serial cabling, no connectors, and build the product, put it in a box, and put it on a shelf.
Right.
Now you can program the device in a box through RFID. You can set parameters, serial numbers, time zones, usernames, user information, and then let's say it's a portable device and you program the device while the batteries are in storage, and I pull the batteries out of storage and actually start using it. The product could self-configure itself, and then when it boots up, it can go, hey, Greg, how are you? You're in the central time zone. You like the White Sox.
Right.
You have a son and your dog, Lucy. How's she doing? And then I go, wow, that's awesome. Like, it knows something about
Right.
me. As an engineer, you're thinking about it just to get things through the logistics chain a little bit quicker.
Right.
But then in a servicing and maintenance phase, you can then use the device to connect to it with an NFC phone and take information out of memory. So let's say you have a product where that product failed in the field and you were keeping performance information stored in the EEPROM memory. Now you don't have to fix a device before servicing it. You can just pull that information out of the data and send it through your phone to the web.
Right.
It's a pretty interesting product to use from start to finish.
So you mentioned this EEPROM technology a couple times. How simple is it to integrate? It sounds kind of complex.
From a hardware perspective, it's very easy to integrate. If you are using a E-square already in your product, we've kept that pinout the same of this product so that you could do a change in the layout by just adding a PCB antenna and one trace from the device back to your SoC so that you can use it as an interrupt to let you know that there's something with RFID going on. But hardware-wise, with just a PCB change is really all you need to integrate this device into your end product.
Fantastic. So let me get this right. You said the pinout is the same.
Exactly. It's exactly the same. If you look at the standard serial EEPROM that we offer, we take some of the no connect pins and we repurpose those for the voltage output and the antenna connections, and then also add the work in progress pin to the device. So you can really do a running change from a standard EEPROM to this product.
Wow, very cool. Okay, Greg, I must admit I'm a little worried about that antenna there. I've met some of those antenna guys, and Greg, am I going to have to grow a beard? Is that what you're saying?
No, it's really a beardless design. So we have application notes available that walk you through the process of antenna design.
Good.
So we give you all the math. We give you all the design methodology needed to design a good antenna. We also give you the methodology needed to use test and measurement equipment to validate your antenna design in a step-by-step process. But along with that application note, we provide software so that you can compute your own PCB antenna. So you enter your geometric parameters, and it gives you the inductance that you need in order to connect an antenna effectively to the product. We also provide a bunch of different reference designs for these products where we have some different antenna boards from 15 by 15 millimeters all the way up to credit card size.
Okay, Greg, let's take a closer look at those boards.
When you take a look at those reference designs, again, we have credit card size down to 15 by 15 millimeters. When you take a look at those boards, we have a 16K bit EEPROM on there. with a pin for the work in progress busy connector and a pin for the voltage output and pins for the I2C connection. So the idea behind these boards is, hey, I can take a soldering iron, hack them into my end product, and do a very quick proof of concept with these antenna boards.
Very nice.
We also have a bunch of different RFID reader writers available.
Okay.
So we have a couple different demo kits that you can use for industrial reading and writing, also down to very simple connect to the PC RFID reader writer boards that you can interact with these products.
Okay, Greg, you show a lot of different reference designs for antennas, but what about the little systems?
We have a couple different reference designs for these systems. We have a couple reference designs for data logging, and we also have a brand new one called the M24LR-Discovery.
Okay.
In this kit, you get a little reader-writer board, the CR95HF, plus this red board. On this red board, you have a M24LR product, and the energy that's harvested from that product goes and generates power for the STM8L, which is a low-power microcontroller, and a liquid crystal display. So with this board, when you put an RFID reader-writer there or an NFC phone, the energy harvested from that connection is utilized on this reference design to power this whole board.
Sweet.
Yeah, it is really interesting. And on this voltage output, you could get 1.2 to 4.8 volts at a maximum of 6 milliamps from that board. So again, it's really meant to be a reference design for power autonomy.
So, hey, Greg, I kind of want one of these. Can we talk after we're done here? Maybe you know somebody who can get me one?
Actually, I know Mouser. So if you look for the kit through Mouser, you can get the kit very inexpensively. And the kit includes a CR95HF reader writer. And it also includes this M24LR on a product that includes the STM8L and the liquid crystal display. So it's a very simple way to get NFC connectivity.
Fantastic. Okay, Greg, this is great, but what about the software? It scares me a little bit. Do I need sandals and a tie-dye along with my new beard?
Yeah, it helps you relate to the software people for sure, but we really try hard not only from a hardware perspective to help you get from a proof of concept to a production state, but
good.
For software integration, we provide an Android app that you can interact with the M24LR Discovery board. And basically, if you have an NFC Android phone, you can go to the Google Play Store. You can search for NFC V-Reader.
Okay.
You can find the app online to interact with the Discovery Kit. We also provide a PC GUI and source code for the Android app that you'd find online as a reference and as a framework for you to develop your own app to interact with the product. So that code is provided license-free, royalty-free, and free of charge.
That's really cool. Okay, Greg, I think I'm ready to get started. What's my first step?
Really, the first step is to understand what type of memory density you need. We provide 4K bit for just simple tap and exchange and tap and pair type applications. We provide a 16K bit for that and a little bit more.
Okay.
Hey, I want to program a MAC address. Hey, I want to program a serial number. We provide the 64K bit product for applications like data logging or anything else that would need some deeper memory.
Sure.
We also provide the product in 3 main packaging solutions, but we also provide wafer and die form. So if you needed to integrate this just like a traditional RFID product in an RFID inlay, the product can be made available that way as well.
Fantastic. Okay, I must admit this has been quite a bit to wrap my head around, Greg. Can you boil this down a little bit?
Yeah, in conclusion, the product's innovation comes by having a block of memory being able to be accessed through RFID and I2C. It's also built on our highly reliable eScore technology. It has the energy harvesting feature that enables little power autonomous subsystems. It's an NFC dynamic tag and allows that simple connectivity that in the end will give your end user a richer product experience.
Great. So I understand you guys have a seminar series that goes along with this?
Yeah, we have a seminar series that we've traditionally done for our microcontroller products. This year we'll have a new product being released called the STM32L. It's a low-power 32-bit microcontroller, and those will be available in a bunch of different cities across the U.S. But in general, what we've done to modify this seminar is to add the M24LR to it. So you'll go through the same process of the seminar and learn about the product, and then towards the end of the seminar, you'll then be able to connect an M24LR to the discovery board that you'll get for the STM32L. And now you'll add the simple wireless connectivity, and you'll be able to interact with that board with a phone, if you bring an NFC phone, of course.
Cool.
You'll be able to interact with the STM32 through the M24LR is your NFC connection.
Very cool. Well, I think that's all I have time for today. Thank you so much for joining me today, Greg. It was a pleasure speaking with you.
It was a pleasure speaking to you. Thanks a lot for the time.
And before we go, don't forget to click that Download Now button below the player to download a free white paper that further expands on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.